Here we go. So, hey, it's February. I like that. Because March is coming in a month, and March means spring. Hallelujah, huh? Okay, so today, our objective is basically what we need to find is finding find the vertex, and line of symmetry from parabolas. Okay, so we're going to find the vertex and the line of symmetry from parabolas. Okay. Well, if it's already in vertex form, it is easy. Okay, vertex form. So what's vertex form? We've seen this. You guys already know what vertex form is. It's when it's quantity squared. It's like the parentheses squared. Okay, and vertex form is really nice because you can get the vertex right away. Okay. So the vertex, and again, in math, when you see minus or negative, it means opposite, doesn't it? And even in the formula, you see the negative, right? Which means opposite, right? We talked a little bit why it has to be negative. The reason it has to be the opposite because whatever value this is, we need to zero it out. That's why you do the opposite, because the vertex should either be the lowest value, right? Or if it's upside down, the highest value. So whatever value in here to zero it out would have to be the opposite, right, to make that become 0. Okay, that's why it's the opposite. So vertex form is HK. Oh, my goodness. I'm going to have to fix H plus K. Look at, there's a mistake I'm going to have to fix. HK. But you already knew that, didn't you? Right? So to find the y-intercept of any graph, if we took a look at a really easy little graph, again, I want you to know why this stuff works. Okay, if I drew in a parabola, any parabola, it doesn't really matter. I'm just going to draw one in. Okay. If I look at the y-intercept is right here. This is my y-axis. My y-intercept is going to be right there. If I think about it, on my x-axis, the y-intercept is where it crosses the y-axis, but that's where x would be 0. The x value would be 0, correct? Right here, the x value would be 0. To find the y-intercept, then you just let x equal 0. Easy. And if I think about my x-intercepts, here and here are my x-intercepts. There's two of them in this case, right? If it's on the x-axis, that means its y value is 0, right? It's high to 0, so it makes sense. If you let y equal 0, then you find the x-intercepts. So it's as easy as this. If you want y-intercepts, let x equal 0. If you want x-intercepts, let y equal 0. Easy peasy, right? Hopefully it makes sense. And then, so example 1, let's graph this, and let's find the line of symmetry, vertex, y-intercepts, and x-intercepts. Okay? Now this was not too bad. In fact, I think we did this one in the warm-up. So first of all, the line of symmetry, if we know our vertex is at 2, -4, right? -2, so it's the opposite, +2, 4. Then the line of symmetry has to go through the vertex. I mean, the line of symmetry cuts it right down the middle, so the line of symmetry, line of symmetry. It's a line, right? It's a line, so it has to have an equation. It's a vertical line, it's an x equal equation. So line of symmetry is simply x equals 2. So the line of symmetry is always going to be an x equal equation because it's a vertical line, right? And it always has to go through the vertex, so it's x equals whatever the corresponding x value is, right? Now, the y-intercept, and I can get the y-intercept by graphing it, but I want to do it by using the math because it doesn't always work, but the math always works. Okay, so if I want the y-intercept, we're just going to let x equal 0. Okay, so y-intercept, let x equal 0. Okay, so I'm going to do that. That's going to be my y equals 0 minus 2 squared minus 4. Okay, so I'm going to let x equal 0. I just plug 0 in for x. And I'm just going to solve, okay? So I'm going to go y equals a 4 minus 4. You guys okay on the 4? Got -2 squared. -2 squared is 4. 4 minus 4 is 0. Correct. Tell you right, Daisy. So I get an answer which is 0, so I get an answer of 0, 4. 0, 0, my bad. 0, 0. Because if I let x equal 0, and I get y value of 0, so I get a 0, 0 for my y-intercept. My x-intercepts are going to be to let my y equal 0, okay? So I'll have 0 equals x minus 2 squared minus 4. And again, we can get this from the graph, but you can't always. I want to show you the math behind it, okay? So x-intercepts, let y equal 0. X-intercept, let y equal 0. So let's solve. I'm going to add the 4 first. So I'll go 4 equals parentheses x minus 2 squared. A lot of times there's 2 x-intercepts, right? Often there's 2 of them, so I'm going to need probably 2 answers. So when I take the square root of both sides, the square root of 4 is 2. The square root of 4 is 2, but it's also negative 2. It's also negative 2. Okay, so we're going to say this is plus or minus 2 equals x minus 2. Okay, plus minus 2 because negative 2 times negative 2. I'll say it again. Negative 2 times negative 2. Negative 2 times negative 2 is 4. 2 times 2 is 4. Okay? 2 answers. Whenever we have an x squared in an equation, we will always have 2 answers. Remember that from last semester? X squared, 2 answers. You guys remember that? I don't know how many times I said that. Right, Rory? A lot. Yeah. So, I'm going to have a 2 equals an x minus 2, and I'll have a negative 2 equals an x minus 2, plus 2, plus 2. One answer is 4. Plus 2, plus 2. The other answer is 0. So, an x-intercept is a point. An x-intercept is a point. So I have a point at 4, 0, and at 0, 0. Okay, so let's graph it. From all the information I have, let me highlight the stuff I need to graph. I need to graph this point, y-intercept, x-intercept, x-intercept, right? I've got my vertex and my line of symmetry. I want to graph all of those and put those all down on my graph. Okay, easy. So first of all, I'm going to start with my line of symmetry, which is right down. I like to make it, it's like an invisible line, right? It's like an invisible line that goes right down the middle. Yes, Daisy.
So, because it's plus or minus 0 and it's a negative 2 by the x, wouldn't it be negative 4? But at the same time, that wouldn't make sense.
Wouldn't make sense, would it? So if I go plus 2 here, I would get 0, right?
Oh,
It's okay.
negatives.
That's okay. I didn't show that step, so I don't mind doing it, okay? So let's graph it. I've got my line of symmetry. It goes right down the middle. I have a vertex at 2, negative 4, right? Has to be on the line of symmetry. The vertex, right? Has to be. I've got a y-intercept of 0, 0, and I have x-intercept at 0 and at 4, right? And I can just graph my parabola in. Okay, that's pretty easy. You guys agree? Oh, I missed that one. You didn't really need the math to graph it, correct? But you will later. You will need the math to graph them later because you won't get such simple graphs, okay? Thumbs up. Are we good on that? Okay. Turn the page. Now, what if somebody took this answer, or this question, and foiled it all out? Let's say some dum-dum just happened to write it like this. Don't write this down. Just don't write this down. But what if some dum-dum wrote it out like this and multiplied it all out, x squared minus 4x plus 4 minus 4, blah, 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 and foil it all out, and then you end up with a equation that looks like this, right? It's a trinomial in standard form. So if it's a trinomial in standard form, it still is a parabola. It's still a parabola, okay? But finding the vertex is a little bit more difficult. So here's this little mini equation, negative b over 2a. So a is the number in front of x squared, b is the number in front of x, and c is just the constant, okay? So we're going to use this equation to find the line of symmetry. So, and then the vertex lies on that line of symmetry. We'll be able to get the vertex from that. And we'll still do the same thing for x and y intercepts, okay? So let's take a look at example 2, okay? If I want to graph this. So first of all, line of symmetry. Line of symmetry. So it's not in vertex form. we're going to have to use our little formula. So it's easy. We're going to go x equals negative b over 2a. And I'm going to highlight that formula because that is a super, we're going to use this little mini formula a lot. Okay, that's our formula. We're going to use this one a lot. So in our example, a is 1 because it's a 1x squared, b is 2, and c is negative 8. So x is equal to a negative 2 over a 2 times a 1. Negative b, which is 2, over 2 times a, which is 1, okay? There's my negative b, my negative 2 over 2 times 1, okay? And if I simplify that, I get a negative 2 over 2, right? Which is negative 1. All right, so what I can do is take that and put that on my graph. So I've got a line of symmetry at negative 1, okay? So like an invisible line that goes right down the parabola, okay? So just put in my line of symmetry right on down, okay? Now, the vertex has to lie on this line, correct? So I know the x value of vertex, x value of the vertex is negative 1. To find the corresponding y value, let's plug it in, okay? So let's plug it in, okay? Plug it in. Plug it into what? Well, the equation, right? So to find the vertex, we're just going to go, and I know it's negative 1 something, negative 1 something, so let's plug it in. So take the negative 1, and let's plug it in for x. So we'll go, okay, y is equal to a negative 1 squared plus 2 times a negative 1 minus 8. Can I borrow your calculator real quick? Okay. Now, I'm okay with using a calculator because sometimes kids make mistakes. I make mistakes, right? So if you want to just take your calculator and let it plug it in, okay? So you won't mess up on your negatives. Parentheses, negative 1 squared plus 2 parentheses negative 1 minus subtract 8, right? Just put it in. I get negative 9, okay? You guys see that? It's okay to let the calculator do the work because you may make a dumb mistake. I'm not calling you dumb. I make dumb mistakes because negative 1 squared is a positive 1, correct? So I get negative 9. So y equals negative 9, negative 9. So, okay, good. I've got my vertex. I got my line of symmetry. All right, now, same thing. Flip the page real quick, and I'll flip it back. X-intercepts and y-intercepts. Okay, so to get the y-intercept, same rule. Just let x equal 0. Let x equals 0. So I can do that. I can go y equals 0 squared plus 2 times 0 minus 8. Well, that's pretty easy. Negative 8, right? But we already knew it was going to be negative 8 because of the negative 8 here. So, all right, I've got a point at 0, negative 8 for my y-intercept. Awesome. Now my x-intercepts. We'll see if you remember how to factor. And if you don't remember how to factor, that's okay. I'm going to throw it at you anyway, right? So if I let my y equal 0, I'll have 0 equals x squared plus 2x minus 8. Again, we need two answers. Two answers, x squared, two answers. Okay, so, all right, hopefully you guys remember how to factor. If you don't, I'm sorry. We're gonna have to remember x and x. What times what makes 8? You already got it. 4 and 2. How about a positive 4, negative 2, right? Because they have to multiply to make negative 8, but they have to add to make the... Everybody good? I mean, remember factoring? Everybody thumbs up on factoring? Okay, we did a lot of it last semester, didn't we? A ton. So if I solve, I got my mini equations. I got 0 equals x plus 4, 0 equals x minus 2. And I know you guys, a lot of you don't even do this step, do you? Go straight to the answer, right? So x equals negative 4 and x equals positive 2, right? So, negative 4, 0, 2, 0. So, okay, let's see. Negative 4, 1, 2, 3, 4, and 1, 2. And my vertex is at 0, 1, 2, 3. So I've got my x-intercepts. My y-intercept at 1, 2, 3, 4, 5, 6, 7, 8, right? My vertex is at negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I've got one more point I'm going to put in, and that's right there, right? You guys agree? I'm going to put one more point in there. Because it is a reflection over the line of symmetry. So if this point would fold or reflect over here. So there's one more point, right? Then I can just graph in my parabola. Okay, these are pretty easy examples. Yeah, Daisy.
Isn't it supposed to be a positive and not one? Yeah.
Oh,
So,
yeah, huh? Thank you. Yeah.
You got it, Mr. D.
There you go. Yeah. Have you ever known me to make a mistake?
yes.
Yeah.
Never. Okay, thumbs up. Okay, now these are two pretty simple examples. You're going to see a little bit better examples on the homework today, but that's why we've got time to do it. So let me go ahead and stop the recording.